Hi, Louis.
Hello, are you recording?
Hi. Yeah, I think few people have joined. Are they?
Well, I'm ready.
Okay, 1 minute. I think let's. I have few announcement.
Sure.
Okay, thank you. Hey everyone. Thanks for joining today. We are actually today we are going to talk about the API building series part 4, and we are Microsoft Singapore user group, technical community, and there are a couple of communities under Microsoft Singapore, technical Singapore. In that, Azure Singapore is one of them, and if there are also other of them like data and AI, and if you're .NET community as well. So if you want to join Microsoft technical community, so there is a Facebook link, so you just need to type MS Technical Communities SG, so you can join there. And there is also a meetup group, so you can just type MS SG UG. And we also have our YouTube channel, so all our session recordings are available on the YouTube channel. So if you are interested to see our previous sessions, all sessions you can see on the YouTube link. And if you would like to present or maybe organize the sessions, you are already you are welcome. You can contact any one of the organizers here. These are the email IDs which is given here. And some of the sessions we have done in past. These are, so this is the API building series we are running from past 2 months almost. Yeah, so there are 3 sessions we have done already. There is by Lohith. So there was first was designing the API and DevOps for the API and implementing the API. There are 3 sessions. These are 4 sessions we are going to do today. So all the session recordings are available on Azure Singapore, this Azure Singapore bit.ly link. So you can just click on the link. You can just go on the link and can explore. And before that, we have done a couple of DevOps series. So all the session recordings are available on our YouTube channel. So you can just go and see there. And apart from that, this is today's session. Today's session is implementing the consumer. This is the part 4 of the series. And Lohit is going to means discuss today how we can implement the APIs for the consumer. Before that, he have explained in part 1 designing the APIs, and then the part 2 he have explained about more on the DevOps. And then we have talked about means how we can means build the APIs. Then this is in part 4 is going to discuss about the implementing the consumer. About Lohit, he is a tech lead at the Xamariners. He also Microsoft ex-Microsoft MVP, and he's technical evangelist for the Telerik. And there are some related sessions for the API building. So if you are interested, you can just go and explore for the microservices and the API, which Lohit have already done before. And this is our YouTube channel. So if you are interested to see that all the recordings of our previous sessions, so there are a couple of good sessions available. You can just go and subscribe that. And we have also done some chartbuster sessions before, so that are also available on our YouTube channel. And before taking with Lohit, so there are a few reminders. Please keep yourself on mute. And if you have any questions, so you can raise hand feature. And this session is being recorded. And if you like the session, please spread the words on social media. Okay. Now over to you, Lohit.
Okay, so just give me a second. I'm going to set my monitors.
Sure.
Let me get my presentation. Okay, so now, oh, I'm not able to share. It says only meeting
Just
organizers.
that. Yeah, now you can try.
Yes. Yeah. Okay, so as Asif said, this is the last series in the last part in the series. We've been doing the serverless architecture real world end-to-end application demo from the last three parts. Basically, we have been going through this almost like 2 months, as Asif said. I hope this journey has been a good journey for everybody. Our idea was very simple. I'm a fanboy of serverless. When you can just write 5 lines of code and then leave every infrastructural things to the cloud provider, why crack our heads onto that one, right? So serverless is great. Yes, it has both pros and cons. You don't know what you're doing, well, you will end up with the pitfalls. But once you know how it works, it's fairly simple. I just want to build an API, and I want to focus on my logic. I want to focus on my business, whatever needs are there. I don't want to worry about what kind of server, how to run this, how to scale this. No, I don't want to do that. That's what serverless is all about. You as a dev or you as a team, you can focus on your logic, and then you leave the infrastructural things to the cloud provider. Today we are talking about Azure. Well, you may be coming from GCP, the Google Cloud, or AWS, or Alibaba, or DigitalOcean, you name it. So the cloud providers, they all have their own way of providing the serverless. I know for sure um, uh, the Azure, the GCP, the AWS, they all have serverless offerings. So it's called as Azure Function. On the serverless itself has become very broad now. So far when we talk serverless, it used to be only Lambda. AWS Lambda. Lambda is nothing but a function. But on Azure side of the things, there are plenty of serverless, offerings available. I can get SQL Server as serverless. I can get Cosmos DB as serverless. I can get Logic Apps, which is serverless. You don't do anything with Logic Apps hosting or anything. You just go and say, I want to build this Logic App. Everything else is taken care by Microsoft. So the serverless itself has evolved. But we are focusing on this journey on one aspect of serverless, which is I want to build an API in a serverless manner, and that's Azure Functions. I put it as real world end-to-end application demo because I just wanted to show how I do in my team, how we do in our company with my team. That's the experience that I've been sharing over the last three parts. In this part, well, that's about me. I think Asif gave it. If you have been a regular, you know what I'm going to say about myself. Yeah, so this is the series. We started out with designing the API. Then, probably this is something that you would never expected, which is like after designing the API, we're going to do the DevOps. That's something that, you should go and then take a look at this particular, series, the second part of this series, and you will understand why I build the DevOps first before implementing the API. Then we implemented the API in the third part. In this part, I called it as consumer, but well, if you have an API, anybody can be consumer. Your postman is a consumer to your API. But what I meant to say was we will implement a client who consumes this API. So that was the notion about implementing a consumer. I want to build. I have my API now. Well, API alone is not enough. It needs to be consumed. The data, the main purpose of building the API is I want somebody to probably consume the data that I have. So that's why you build the API in the first place. This part is all about building a consumer. Um, just running down the same prerequisites. You should have familiarity. If you're coming for the first time into this series, this is the first video, first webinar you're attending. Well, you better know .NET. You should have heard of Azure. Serverless as an architectural pattern. Then you should have heard of Azure Function, and then of course you need to know the C#. The problem statement that we are working on is you're part of API development team at Contoso Limited, and in the part 3 we have already built an API. The task was you have been tasked to develop an API to manage employee to-dos. As I said, when I build a client today, it's going to be a web application, but that's one of the examples of consumer. you can go ahead and then build a console app. You can build a Xamarin Forms app, which is a mobile app, or you can build anything that can connect to this particular API. Even Power Apps, maybe that's the newest low-code platform that's coming up with Microsoft. So today I'm going to be focusing on building a web app which the employees can connect to. And when they log in, well, we know who they are. And then based on their login, we're going to go and then allow them to create a to-do. And then we're going to show them all their to-dos. The focus is not on how we are building the UI. I'm not going to fancy the UI, or I'm not going to build a fancy stuff. My point is to showcase like this is how once you have an API using building a client, how do you do full stack? Like, I started out with Azure Serverless with Azure Function and then C Sharp. I built my API in C Sharp. Now today we're going to be looking at a mechanism of building the client side with again C Sharp, no JavaScript, nothing. So it's like full stack from API, from backend to front end. We are doing completely C Sharp. Um, this is this architecture is typically what majority of the projects follow. Um, Gone are the days where your APIs are residing within your ASP.NET Core or ASP.NET application. Way back when ASP.NET started, we all are aware of the view controllers. Plus, you could go ahead in the same project, you could go ahead and then create a API controller. So now you have one project where you have a view and then an API. Well, that's something known as a server hosted, right? It's basically you need a server where you host this, and then server needs to process this and then send it back to the client. Slowly we evolved, and then there are the concepts of single page application started, SPAs as we call it, which is what it says. It's a single page app. You just load one single page, and then in that single page everything starts happening. You have a routing coming in, you have different sections coming in, you have different pages coming in. So that's typically how you will, in the modern day, building a web application, that is how you will do it. You will use ASP.NET Core as a basically a server to host your pages. You need somebody to serve your HTML and JavaScript and CSS to the client side. So that somebody is a server, and that's and technology that you can employ for that is ASP.NET or Node.js or JSP, you name it. So it's of not of a prominence. Once your JavaScript, your HTML, and then your CSS comes down to the browser, that's it. From there onwards, you have another framework like Angular, React. Now I'm going to be talking about a very specific technology called Blazor. I've been following Blazor from the days when Steven Sanderson, that's the guy who is responsible for making Blazor a product in Microsoft. This was experimental until last year. Microsoft did not make it a product until last year build. Build 2020, I believe, is when the Blazor server side became GA, or globally available and generally available. That means Microsoft will assist you if you have any problem with Blazor server side. But there is another aspect of Blazor which is known as Blazor WebAssembly. I just put it as a Blazor client on this deck, but we are going to be doing what's called as a Blazor WebAssembly, meaning WebAssembly is a technology that probably gained momentum 3-4 years ago. It's nothing but the way you have native code that your operating system understands. WebAssembly is a native code for the browser. This is the instruction at the low level that the browser can understand. And what Blazor WebAssembly does is it takes your .NET code, converts it into WebAssembly, and then ships it. Sorry, it doesn't convert your code to WebAssembly. Rather, Microsoft has already, we call it as, there's a, all kind of buzzwords that are available. We call it as WASMified .NET. Basically, the .NET has been, our Mono has been converted into a WASM. The WebAssembly version of Mono is run on your browser. And once your browser now has .NET, well, it can just do any of your .NET code. So we download the DLLs in which your C# code is written onto the browser, and there is already a Mono runtime or the .NET runtime running inside your browser, and then it understands how to pretty much provide instructions to the browser. So your Blazor code is doing nothing but it runs on a browser sandbox and it's doing the DOM manipulation. If you're coming from Angular or React or any of the front end UI frameworks, they all do exactly the same thing. They just manipulate the DOM, right? You, instead of you going and then saying like document.get element by ID, and then once I grab hold of that particular element.inner HTML is equal to whatever HTML, what Angular or React or Svelte or you name it, there are a bunch of UI frameworks available. What they do is they do the DOM manipulation for you. And then of course, because it's a framework, you get all sorts of benefits. Like I make one change for a variable. Well, the framework notices that, oh, there is a variable. I mean, the value got changed. Okay, I got to repaint my DOM. Yeah, so all this repainting, all this reactivity is all provided by these frameworks. Today, we're going to be looking at Blazor. Blazor is very, very dear to me. I keep doing a lot of Blazor related stuff. If you go into my repo in GitHub, you will start. You'll see a lot of Blazor related small repos that I do. I keep building basically sample apps. I've built when Angular came up. Angular has a very small, simple a sample application. It's called as Angular Heroes. And I converted that into Blazor. So I created a Blazor Heroes. Basically, it's a bunch of heroes being shown. It's like a to-do application, but I said like, okay, instead of doing to-do, let me start doing all those things. I have a bunch of Blazor sample apps that are available on my repo. So what is a Blazor? Well, Blazor is a new technology. Lets you build front end, lets you build UI applications with just C#. Of course, there is a JavaScript interop available, but so far, whatever I keep doing, there's a hardly any JavaScript that I do. Basically, if I just need to show a bunch of data on the screen, well, it's C#. If I want to insert a data, well, it's again a C#. If I want to, delete data, well, again, it's in the button click, and then I go to the web API. So having said that, being in the C# land, it doesn't mean that you cannot talk to JavaScript. There are interops available between Blazor and the JavaScript layer. You can call .NET from JavaScript, or you can call JavaScript from .NET. Both, back and forth is possible. That's what Blazor provides. Now, because we are Contoso limited, I just cannot let anybody to come into my web application, right? I need to know that Lohith is a member of Contoso's, company. Is part of this organization. What better way than the Active Directory, right? It may be anything, but I'm making use of I'm making use of Azure AD as an example here, meaning Contoso has an Active Directory. It's hosted in Azure, and only authenticated users can access my web application. So I need to make sure that my web application cannot be accessed if you're not an employee of Contoso. So what do? We protect our web application to say that, look, hey, web application, you should be you should allow somebody only when they're authenticated, and then it has to be authenticated by so and so Azure Ready. We're going to look at all those stuff, but that's the setup that I'm trying to explain. My web application is protected against the Azure AD, and then we have already built the to-do API. I'm going to show you the to-do API. I finished all the CRUD operations on the to-do API, and then basically it connects to the to-do API and then shows the data onto the web application. That's as simple as it can get with the this particular application. Now, to start with, what I'm going to be doing. To start with what we did in the previous, let me just bring up one of my REST clients. I am using Insomnia today, I think. Yeah, by the way, feel free to ask questions if you have any. I'm going to be looking at the question chat window. So let me go to what I've done is I'm making use of my backend as what's your GitHub repo you mentioned. Somebody's asking. Oh yeah, okay. It's let me flash it. If you go to github.com/lohithgn, that's my GitHub repo. So let me just put it into the chat window. So that's my repo. Okay, any more questions? No. Okay, we're good. So what I've done is I've made use of Cosmos DB as my backend. I love Cosmos DB also. It's fantastic NoSQL database. Why I like Cosmos DB is because Cosmos DB and Azure Functions, they have a very good coupling. It's not tight coupling, but rather it's a very good disconnected coupling. Azure Functions provide you a concept of what's known as bindings. So what I could do typically is I could just tell my Azure function is, look, I have a binding with Cosmos DB, just write data into that or read data from that. So all those things can be done using what's called as a Azure function Cosmos DB binding. There's a bunch of bindings available in Azure function. That's why, again, Azure function is one of my passion. And then I like it a lot because of all these neat things that Microsoft has done, and then it lets me do my job faster. It lets me do my job more efficiently. I don't need to spend too much time. When we have a concept, I'm a guy who's like, okay, let's first discuss the concept. Let's worry about have we taken care of everything. Once concept phase is clear, once we have ironed out everything, how soon can I build it? Well, with function, it's like within a couple of hours, I can stand up the whole API layer to whatever I'm building. And with all this, I remember way back in 2017, one of my colleagues is here in the call. We had to delete data from Salesforce. Okay, but the data to be deleted would be given to us from some department, and it's basically in a CSV format or JSON format, whatever, right? So when they dump, each file used to have like 10,000s of records. You wouldn't believe I was able to just create the whole end-to-end kind of concept using just Azure Functions running locally on my desktop, then running Azure Compute Emulator on my desktop. And Azure Functions had a binding with the blob storage. So that means I could just dump a file into the blob storage and my function would get triggered. And then I would then go to Salesforce and then do a record delete, come back, update if the record was deleted or not. Everything I was able to just build it on my local, show it to my team, and then like, look, if this is okay, we're gonna go production. And that's how it is. I think it took me like 1 or 2 days to iron out everything end to end, and then that's it. So that's why I like working with functions. If it is possible for me to build something in function, that's the first thing that I will do, because it makes me faster to market. It helps me go to market faster. So with Cosmos DB, one of the good things that the team has done is they've given you an emulator. I'm running this emulator. If you notice my, I'm not sure if my resolution is correct, so I'm sorry about this. Let me just quickly get the resolution right. I think I need to be, it's clear. Okay, sometimes people have a hard time reading some text, so I need to be on a very low resolution. So you should be able to get this now clearly on your screens. Yes, so 1080. I'm now on 1920 1080 now. Okay, so what Cosmos DB team has done is they've given us an emulator. This is running on my local desktop, but it does exactly what you can think of on the Azure, except there are certain things which when you're doing a prototype like this or when you're doing a demo like this, it's fine. I don't mind those lacunae that's there in the emulator. Emulator does not support everything. That's the key here. That's it. But because it's an emulator, it also has a connection string, which I can usually pick it up and then put it into my local settings.json. And then what I've done is I've already created the database. I've already created the container. If you remember, in the part 2 in the DevOps, we have already done this. If you go to the part 2 and then take a look at the infra script, you will see that we have the Pulumi script creating a Cosmos DB with a Cosmos DB account. The way this works is you should have a Cosmos DB resource, and then you create a database, and then you create any number of collections. I mean, I named it as to do SQL container. It can be anything. And then inside the container, you will have an item. So what I'm doing is I've created a collection for to-dos, and then these are all the to-dos that I've been playing around. And it is nothing. It's just a JSON that gets stored, right? Remember, this is exactly the columns that we have as part of the to-do item model that we created as part of the Open API spec. There is an ID, there is a user, completed, created, is completed, and then text. User is this is my email address that's being used. What I'm trying to do is I make use of the email address as a unique record identifier. If you see here, /user means, okay, this is the unique key. It can't repeat. So sorry, this is a unique key. It's like a partitioning of the data. So if I say that, look, go ahead and then give me anything based on this email address, even if I have a million email addresses in this collection, because I made this as a partition key. Now Cosmos DB has an index on its own for this field. So it is like a sub-millisecond reads that we get when it comes to reading data from this particular collection. So I've already done that. So I'm going to be showcasing the API connecting to this one. So let me show it to you. Let me bring up my. So if you take a look at part 3 implementation code, I've already finished the API with the entity frame. So entity framework core comes with Cosmos DB flavor now, meaning you can use entity framework to connect to Cosmos DB. Maybe I will show you a code in a just a bit, because I did not do this in the last. I just finished it afterwards. So it's very simple. You just need to add entity framework .cosmos. That's the package that comes in, and then I've already created a to-do. Although this is a NoSQL, meaning it's like a JSON based database, the concept entity framework brings in is completely different. It's like, hey, look, you have a DB context. So I've created a DB context. Notice here, I've created a DB context. I'm taking a dependency on the configuration because I need to know where should I connect to? What's my connection string? And whenever the context is getting configured, well, I will say like, oh, look, you need to use a Cosmos. Here is the connection string, and here is the database that you need to create. And then I'm saying that I have a model called to-do item. It should be mapped to a container called to-do SQL DB container. It has a partition key called user. That's it. I'm just giving entity framework some hints on how it should communicate with Cosmos DB. There's a bunch of options available, but this is the bare minimum that you need to do. If you look at my local settings, I've already added the connection strings, everything. Again, we are doing the best practice. If you notice part 3 in this series, I'm not setting the connection string in my local settings.json. This is fine. This is not a secret. Nobody can do with this name, but yes, the connection string is a secret. When I'm working locally, the connection string is set to the local emulator. So let me go and then say manage user secrets. Notice here, this connection string is set to local emulator. But once I deploy this to Azure, the infrastructural script has already taken care of updating this particular function resource app setting called to-do connection to the actual Azure Cosmos DB connection string. It has already been done by the infrastructure. That's why I said I like to do the infra DevOps as a before even doing any implementation. So I've already set up to do connection string. Here is the database name. Here is the container, and that's pointing to this particular emulator. Yeah, when it comes to the DB context, well, it's regular entity framework DB context. All I'm saying is, well, I have a to-dos. Now, what I've done is I've also created what's called as a to-do service. Very simple it's like a standalone class, takes a dependency on the context. If I want to list to-dos, I need to pass a user, which is nothing but the email address that we have. All it does is, notice, I do not need to know how to communicate with Cosmos. I do not need to know how to communicate with NoSQL. Why? Because I'm well versed with the entity framework. In entity framework, I know that context dot some collection where item, well, some condition, give me that as an array. That's all. It's going to go to Cosmos, communicates with Cosmos in an HTTP layer, and then gets the JSON, converts it into whatever I'm asking for. I'm asking for a to do item array, and then gives it back. Exactly the same. If I have to create to do, I don't need to know how to create an item in Cosmos, how to create an item in NoSQL database. It just does it for me because it knows that. That's why I like playing with what is available out of the box instead of creating my own. Why? Because this method add async or this to array async or this save changes async is already being tested by Microsoft. I don't need to write any more tests for this. It's battle tested, as I call it. So that's why I like to use what's available out of the out of the box. Don't try to create anything new. First, take a look at what is provided by the framework and then use it. And entity framework core with Cosmos DB is already available. So that's why I got with that. I got in with that. And then reading a to do, if I give an identifier, it's exactly the same. To dos.where, blah, blah, blah. There's an update, there's a delete. Now I'm already running this. So I'm going to bring up my Insomnia. So in Insomnia, what I've done is I have two environments. I call it local and then I call it dev. Local is nothing but, if you look at the app domain, API domain, it is going to localhost :7071. If I change it to dev, well, it goes to Azure's wherever is the Azure's function setup. So this is typically how our team we set up. The moment I have an API ready, we set up a local environment, we set up a dev environment, test environment, production environment, so that the domain keeps changing. In here, if you go to manage environments, this is all it is. I have a variable called API domain. It has a value. I have a same variable API domain. Well, it has a different value. And this is typically what we set up right from day one when we are trying to do an API. And then not only that, Postman has a concept of, I think mock servers. So even before your team is ready with development, you could just go ahead and then say like, look, this is an endpoint, and then this endpoint will return data like that, and then point it to a mock server. And then your testing team, and then if there is somebody else who is depending on it, well, you just tell them that, look, you just try to connect to this particular URL, and then once we are ready, we will tell you how to swap it, and then you can pretty much swap the URLs for them. So if you take a look at this, this is connecting to this is connecting to my localhost. So I'm going to say, give me where did my keyboard go? Okay, so I'm just going to say that give me all the to-dos for this particular user. I have 3 to-dos. So it says task 1, task 2, task 3, just to make sure that I'm not making any magic. So I'm going to go to, let's say to-do number 3, and then I'll say to-do 3 edited, and then I'm going to do an update. Now I'll come back to this, and then I'm going to say send. And you will notice to do task 3 is edited. So it's connecting to my local Cosmos DB emulator. If I have to create a new to do, well, it's very simple. I will say task 4. And then this has to be of course, I'm not showcasing a scenario wherein like APIs also need to be protected. Yeah, I'm running out of time with 4 part, because each one of them takes their own episode to make it. So you can protect your API against the same Active Directory, and you can say that, look, if you're not authenticated, I'm not going to let you in to do this operation. And then we're going to look for a bearer token, and then in the bearer token, it should be issued by the Active Directory, and then it should be issued against that particular client or against that particular API that we are connecting to. That's how typically you secure your APIs. But now, just for the sake of demo, I'm creating task 4. I'm going to say this. Notice I've already implemented this location header also, header value also. It says API to do / this. If you go here, you're going to get the new to do to look at. So I'm going to copy this identifier, go to read to do, then give it, and I get the read to do. If I want to update this to do, I just need to put this identifier. And I can just say like, this is deliver part 4 of webinar. And it is for. So now I'm going to update it. So it says no body returned because, well, it's an update. So if I go back and then read the to do, you will see now the text is deliver part 4 of the webinar. And then of course I can, if I know the to do identifier, I can delete it. So I've already done this. It's the code is there in the repo. And now we're going to focus on building the client. So for building the client, it's very simple. I've already built it. But just to show you how you do a Blazor client-side application, a Blazor WebAssembly application. If you have the latest Visual Studio, you will see a project type called Blazor WebAssembly app. Okay, you just have to select, say next, and then of course bunch of things like what do you want to do. All those things are there. Once you get past this, it's going to ask you how do you want to basically host this. Do you want to host it standalone, or do you want to host it inside ASP.NET Core? So I'm not going to move ahead. What I've done is I've already told Visual Studio that I want to host it standalone, meaning I can build this WASM or Blazor WebAssembly as a standalone single page application, and then just host it anywhere that I want. I can host it in Azure Blob Storage static site, or I can host it in Azure Static Web App, or typically what I do is I host it in surge.sh. If I have to show you one of my previous ones, so Blazor moonface.search.sh. So this is basically a Blazor Blazor web assembly application. Somebody built a Xamarin Forms version of it. So what I did was I took exactly the same code, no changes, but made it as a Blazor WebAssembly because it is C#. And his code, I could just reuse it. So currently I'm probably in the Northern Hemisphere. And then given this date, Moon is in this third quarter. That is all this application does. But what I was able to do is build it, publish it, and then just take the folder and then upload it to surge.sh. That's a free hosting that you get. I use this a lot because, well, I don't want to pay for all my hosting of my demo application. So I just build it, upload it to Surge, and that's it. I'm done. I get the hosting, and then this is Blazor running in the browser. So that's exactly what we're going to be doing here also. And when a Blazor application is created, it usually comes with its own layout and all the stuff. I'm not going to go into that. What I will be focusing on is first and foremost, remember this application cannot be accessed by anybody else. It has to be accessed by only the, let me see where my windows are. Okay, this is the window. So we need to protect it. People outside the organization cannot access the web application. So for that, the best place to do that is we need to go into Azure. This is my personal account. Everybody can get a Azure account. You get some 25 free services, and then yeah, so I have it. So as you can see, this is my email address. And once you have an Azure account, you have your own Active Directory. So what I've done is I've already created an app registration. I call it as to-do client Blazor. It can be anything. So we typically use like this. Sometimes we also do project name dash, what is this, and all those stuff, so that it's easily kind of identifiable. When you create an app registration, you need to have your client ID. This is very important. You need to have your tenant ID. I'm flashing my tenant ID, so I'm going to just keep it on the side for a moment. Let's go somewhere else. Yeah. So I've already set up this registration. This we call it as application registration. All it does is, hey, look, I'm making an entry into your records, and if somebody comes to you from this domain, well, please redirect them to this domain back, like this URL. That's all I'm saying, right? And then this is exactly what I've done, nothing else. In the API permission, yes, I need to read the logged in user. So I'm taking the Microsoft Graph user.read permission. It's a delegated permission, meaning it's not a destructive permission. It's just a read permission because I need to know who the logged in user is once the login has been done. After doing this, what I've done is I've generated the Blazor project. You cannot, oh, sorry, I made a mistake. You cannot generate the Blazor with Active Directory using the Visual Studio. What you will need to do is you will need to jump into command prompt. And if you are in .NET, if you're working in .NET, you know that .NET new is nothing but in command line in .NET CLI, you can go ahead and then create any project of this type. So notice here we have what's called as a Blazor project. If you see here Blazor WASM, it says Blazor WebAssembly app, Blazor server app. So I have gone ahead and then generated the Blazor WebAssembly application. If I go and then do .NET new Blazor WASM -- help, it will tell me all the things that I can pass. So I can tell what framework to build. By default, as of now, we are all on .NET 5.0, which I like. So I'm not a problem with that. So you can say, should this be hosted in ASP.NET Core? By default, it's false, meaning no, it should not be hosted in ASP.NET Core. What I have done is I've used this flag called authentication. Authentication is single arg, meaning only people from my organization should be able to access this particular web application. That's what I've done. And then authority, basically it's nothing but what's the, by default, this is the authority, and that is fine because I'm logging into Azure Active Directory and this is the base URL for that. And then I've given the client ID. Remember the app registration that I did? Well, this is a way to tell Azure Active Directory that, hey, look, I am this application. I have this client ID. Please allow me to, log in. The application needs to be first, a valid application within the directory, and then only it will give you the login form for the user to enter it. And then we also have a tenant ID. So I've already used that and then created this project. What it does is in the www root, it adds an app settings.json, and notice here the tenant ID that I provided is added here, and this is the authority. The client ID is minted here. Well, you may be having some eyebrows raised now, saying like, oh wait, why are we checking in client ID into the www root? Not a problem. This is typically how majority of the front end frameworks work. You need to have at least the client ID so that the server identifies who you are. Yes, if somebody hijacks your client ID, well, they cannot do anything else because this is just to tell Azure Active Directory that I am an application. I've already registered with you. This is my label, right? It's like that. So not a problem with client ID. But if you put a client secret, that's a big no-no. Especially the www root and then app settings JSON goes to the browser side, the client side of the browser, right? It's going to be downloaded. So you don't want any secrets here. This is the first thing it does. Second thing it does is it sets it up for all the authentication, and all the authentication is taken care in an assembly called MSAL, Microsoft Authentication Library, MSAL. It used to be ADAL, ADAL, not the ADAL. Active Directory something, so Microsoft Active Directory Authentication Library, but now it is known as Microsoft Authentication Library. And what it does is in the program.cs, it is going to add this line. And in this line, basically what we are saying is, look, I'm going to be communicating with Azure AD. That's the authentication scheme that I'm using. And I had to add these two. Why? Because by default, the way authentication happens is it is going to bring up a pop-up in front of your website. It's just a pop-up that opens up. Well, I don't want that. I don't like that thing. I want to redirect. So I've said, like, by any time somebody tries to log in, please do the redirection. And I want a token for this particular scope. That's all I have said. And then what I've done is I removed everything. I've done one more thing. I'm not sure how many of you have this, heard or know this concept that you can link files in different projects. So we have already created the to-do item model in the part number 2 when we used auto rest and then we generated the Azure function. Well, it has already created this file. So now what I did was, well, I had the option of using auto rest and then generate it again in this particular project, or I had the option of take out this model from the API project, keep it into its own separate NuGet or a DLL, and then consume it inside this Blazor client project, right? I was very lazy to do any of those things. So what I did was I right click on the models. I said add, I said existing item, and I went all the way up to the API folder, went inside SRC, went inside to do API models. I selected to do item and I did not say add. OK, you got to carefully look at what we get here now. Let me try to do this. There is this small little trick that we used to do a long back. When we had to use the same class file in a multiple project, we used to do this, which is add as link, meaning the file is going to be residing in this particular folder called to do API SRC to do API models. But when this particular client project gets built, so I've clicked on this add as link, and then what happens is, OK, my Visual Studio is acting up. Just give me a second. It has gone ahead and then added a link here. So let me see if I can zoom in for you guys. OK. Notice all the other files have a different what do you call icons. Here I have a different icon. Yeah, it's a C# file. This is what you're seeing. C# is seeing, but in front of that there is a square box that basically says this is not in this folder. This is a linked file. But when I build now the to do Blazor client, it is going to become part of this particular DLL. That's a trick that we used to do like 5, 6, 10 years ago. And then I was lazy enough to do everything. So I was like, OK, let me just bring it in. And then I've just brought it in to this particular project. And then that's all I had to do. Now, the interesting thing is this is my page where I want to show all the to-dos. I just have a table. Oh, I did a wrong thing here. OK, let me just. There are 2 tables. So it's just a, as I said, if you're coming from ASP.NET Core, you already know what this is all about. This is C#, right? And then this is HTML. There's no difference in that. It's very clear. But this is going to be running on the browser, right? Now, all I'm saying is, hey, look, when you are running on the browser, can you take a look at my variable called to do items and loop through that for each item? And for each item, please spit it out like this. What am I doing? I'm just reading the text. I'm reading the created field. I'm looking at is completed. If it is true, well, show yes. Otherwise, show no. That's all. And then I have a form. In order to add a new to do, I'm just going to do a input type, and notice here the beautiful binding syntax or binding expression that we call. I'm saying, hey, Blazor, I have an input type text. That's a text box on the browser. Can you please make sure that you do a two-way binding between this element and this variable? I'll show you where this variable is in a moment. And then I'm saying, hey, Blazor, this is a button, but when somebody clicks on that button, please handle the click event for me. Okay, now so there are two ways of coding in Razer. One way is you just open up a code block and then start writing like string foo is equal to baz. Okay, I'm not a big fan of this. Why? I come from a school of thought wherein like the moment you say .razor or CSHTML, well, that's something related to UI markup. So it should only have UI, no business logic. So what do? In Blazor, we have a concept of everything is a partial class here. So now I just added a C# file I called it as index.razor.cs. Why? Because Visual Studio has this fantastic feature of called nesting. If I created index.razor and then I created index.razor.cs, Visual Studio understands that, okay, these two are related, so I'm going to nest them. Not only that, if you have CSS files with min and then unminified, yeah, take a look at this. So this minified CSS file has a mapping file with the same name. So it's nested them together. So I made use of that concept. And then what I've done is I just created a what we call it as a code behind. We're going back to the web form world. In web form, we used to say code behind. But here it's not exactly a code behind, but this is handling the logic. If you're coming from Angular, this is nothing but the .cs, the .ts or .js file, and then you also have a template file. The template file is nothing but that's the index.razor. It's a template. It's the HTML template, and then the index.razor.cs is the logic behind the template. You know that this logic powers the template. So there are a couple of things that have been already done by Blazor for me. One of the thing is it sets up an authentication state for me. If you notice here, it says cascading authentication state. It has already set it up for me. And then it also provides that, look, if any routes needs a authorization, I'm going to look for it. If the current logged in user is not authorized, I will redirect him to login. Otherwise, that's fine. I will allow him to go ahead and then access the route for that. In fact, in our application, we have only one route. That's the default root route that we have. This is the first thing. A second thing that it does, and it also adds up what's called as a login display. Basically, if I am logged in, it will say hello Lohith. Click here to log out. If I am not logged in, it will say please log in. What I've done is, remember I said nobody can access my web app without authentication. And then currently I have only one web page. So and I've said, well, I need authorization. If the current logged in user is not authorized, he can't access his to-dos. That's what I'm saying. So this is a fantastic feature. Microsoft is building with WebAssembly. I love Blazor for all these facts. And notice I'm still in C#. I've not done anything JavaScript per se. Now, in the program.cs, we have already gone ahead and then set up all the things that we need. We have added a HTTP client as a scope. It doesn't matter because a user will always have only one scope going on. It's not multi-user application when it goes to the client side. So I've already set up HTTP client and I'm saying, hey, I need the client because I want to communicate with my API. And then I want to know what state the current logged in user is. So I'm using a special parameter called cascading parameter that is provided by the app.razor. Then when the page loads, this is the hook that I get on initialized. I'm saying, can you give me the current logged in user? Okay. And then I'm finding his user email because this is a Active Directory authenticated user. Active Directory puts claims onto the token for the user, and then there will be a preferred username, which is nothing but the email address of the user. Once I have that email, I'm saying, go ahead, load the to-dos. So how do we load the to-dos? Very simple. HTTP client, get from JSON. I need you to convert it into this to-do item array. Here is the URL. Of course, you can ask me like, hey, look, you're minting the URLs here. Well, There are a couple of ways that I could have done this. I could have made sure that I put this particular URL into the app settings, and then when I'm registering an HTTP client, I could just go ahead and then say like, look, your base address is localhost :7071. Of course, if I deploy now, yeah, it's not going to work to Azure because now I'm hard coding this, the URL, but I'll change it later. That's all. Once the to-do items is been filled up, if you notice here, I have a to-do items, and then it just updates this variable. The moment this variable is updated, Blazor is smart enough to go ahead and then, paint this onto the browser. The moment there's a change, it will go ahead and then put it onto the DOM. I don't need to specifically go ahead and say like, oh, look, go ahead, update this particular, DOM element because I've changed this. I don't need to say anything. That's why I like Blazor. I just make change to the variables and then it figures it out like, oh, I need to go and then repaint that particular, component. And then I have the button, and then on button click, I need to add the to do, right? So I'm saying on add to do. So what I'm supposed to do? Well, user would have entered the text and I know who the logged in user is. So I'm appending the user email onto this user field. And then again, I just post it to this particular endpoint, localhost 7071 API to dos, and then it is doing an HTTP post, and then it is saying like, look, this is not required because, well, we know it is a to do, so you don't need to do that. And then once I've finished posting, I'm going to set the new to do text to empty, and then again I will load the to dos again because, well, now we just created a new to do. So let's go to the server and then get it back from the server. That is as simple as it can get. As I said, my focus was not on the UI, or my focus was not on the making the UI fancy with update, delete, all those things. My point was to showcase how when you do your serverless APIs end-to-end C#, how you can finish your end-to-end applications using just C# and then Azure Functions and then Blazor. So now what I've done is I think I've already running this. Let me see. Yes, my .NET Watch is running. Oh yeah, so here it is. And notice it has already got the task 3 edited, deliver part 4 of the webinar, everything. As I said, I did not want to make anything fancier here. I just wanted to prove a point. Now I can go in and say post part 4 slide deck or deck. That's another task. Boom, it's done. Right. So now if I show you another, let me see where my another window is. Yeah, it's here. So I'm running the function locally, right? The moment I go ahead and then do something, notice here it says this function was programmatically called by the host API, blah, blah, executing to do listing function, to do create function, to do listing. So if I just keep this guy here and then keep this guy here and then refresh this, you will see here to do listing item coming here, executing executed, right? So I'm not. I can show now like post part 4 code base. And there you go. On the right hand side, the create function is getting it. Of course, you can take this code and then do fancy stuff like I want to edit this task, I want to complete this task, I want to delete this task, or whatever. All those things are immaterial for now. But this is typically what my team does in our company. We are going with Azure Serverless for wherever we can. We try to talk to the customers and say, look, this is where you want to go. For me, what matters most is if I create a ASP.NET Core Web API versus Azure Functions HTTP API, which is economical? To me, Azure Serverless Functions HTTP API is economical. Why? On any given Azure subscription, you have 1 million execution of your complete Azure functions in that subscription. 1 million executions are free. If you cross that 1 million, you're billed only for the next million. And that too, it's like a peanuts, right? I was reading a article the other day. I'm not sure if you guys know this, but there is a fantastic blog aggregation site called daily.dev. Very fantastic. I already have this somewhere. I had it. Where did it go? So let me try to bring it. So what they do is they just go ahead and then, oh, I just disabled. Okay, let me enable it. Okay, so now I'm going to click on this. I know. Sorry, I have a problem. What this extension does is it changes my, when I click on a new tab, I like to see Bing images. I'm probably the only few who like to do Bing, but I have used their PWA. So notice here, this is the daily.dev PWA. So it gets installed as an application within Windows. So what these guys do is they have a lot of resources. They go and then do crawling, and then they aggregate all this information. You will not believe it. They're doing like hundreds of crawlings every day with, I don't know, a huge amount of data coming in. They just pay like $50 per month. That's because they're running on they're running on a serverless offering on AWS. But my point is, when I can run 1 million executions for free, why pay extra for Azure ASP, I mean ASP.NET Core Web API? Because you cannot run ASP.NET Core Web API as a serverless. You need a Azure App Service Plan. The moment you take Azure App Service Plan, you're paying by the hour, right? So whether your application is being, you have a traffic on your application or not, you keep paying per hour. That's not the case with Azure Serverless Functions. If you have a traffic, well, somebody pinged your API, well, your API runs for, let's say, 5 seconds. Your meter is only for 5 seconds. It's not per hour. Your execution is one execution for 5 seconds. Yeah, they just keep looking at your per second execution, and then your bill is prepared based on those executions. If your number of executions is well below 1 million, well, don't worry about the bill. So that's what it is. But that 1 million is not per function, it's per subscription. If you have one function and you run 1,000,000 times in a month, that's it, you're gone. You cannot get another functions inside this 1 million thing. If you have 10 functions and 10 functions together make 1 million, not a problem. Your quota is still 1 million per subscription. So that's why my team, and not only that, we are all C# developers. We are good C# developers. We have been doing C# development for got along 20 years now. So we do end-to-end full stack C#. We have gone ahead with Blazor. It's fantastic. It does what it's supposed to do. If you don't like the fact that the DLLs have been downloaded, so let me show you what I meant by the DLL getting downloaded. So if you go into network tab, probably my things are cached now, so you won't see the DLLs getting downloaded, but let me see. I'm going to do a hard refresh. Yeah, the DLLs are already cached for me. Okay, let me try to do something. I'm going to open a incognito mode, then go get the. Now I'm going to log in. There you go. Are you guys seeing this? So it is downloading all the DLLs it needs. So there is, okay, let me just try to log in. Yeah, I've set up a passwordless, so let me just verify. Yes, I got my authenticator and approving it. Yeah. Yeah, so The second time you don't see the DLLs being loaded, that's because it has already, for this particular browser session, it has already downloaded those DLLs and it's cached now. So that's why it is not kind of showing you that. But yeah, if you go to any, let's see if we can go to Blazor Moonface here, because Blazor Moonface does not have any authentication. So probably I will be able to show it to you that here. So HTTPS Blazor moonface.search.sh. We are almost at the, oh, what did I do? Blazor moonface. Yeah. Um, or let me see one more HTTPS. Blog. Yeah. So this is a new template that I was building. I used what's called as a mud Blazor, package that provides a material design. Notice, because this is the first time, it is trying to download a lot of DLLs, and then yeah, so it's going to face a problem of load. So now it comes up because now it is loaded completely. Well, it's just the first time. Now notice here it has brought down everything. This is my library mud Blazor package, and there should be somewhere uh, .NET also downloaded. Yeah, all the system.dlls, because this is .NET running on the browser now. Microsoft is working towards kind of what's known as ahead of time compilation, trying to get this size small. As you can see, as of now, I'm downloading like a 14 MB payload. Given the 5G coming up, and then I don't know, who knows, we are all in 4G, good Wi-Fi. The second time it's not that bad, like it just comes back 3 seconds, it's going to come back because all the DLLs are now cached. But yeah, so this is something that we are okay. We don't matter about this size, all those stuff. If you worry about size, well, you should be looking at something else. Question: if it is utilizing DLL on client, is it similar with previous ActiveX or DHTML? Nope, it is not ActiveX at all. Keep in mind, ActiveX was like a backdoor into your operating system that is on the client side. This is browser. It's still in the sandbox of the browser. You can the DLL that I downloaded, I cannot do system.file.io on the browser. It will say, oh, whoops, what are you trying to do? You can't get out of your sandbox. So I don't have the file IO or anything. Whatever is available within the browser sandbox context, yes, only that thing can be done. And that's why I said the code that we are writing, it is not doing anything with the for example, I am Lohith, I'm sitting in Singapore. But if this code was hosted in Redmond, I'm not doing, I mean, and if I go to this website, yes, the DLLs are downloaded into my laptop here in Singapore, but because it is sandboxed, it can't do anything. If it tries to do anything, browser will say, sorry, I cannot allow you to do it. And it will throw an exception, security exception. So yes, it is not an ActiveX. It's just a plain DOM being manipulated. But who manipulates the DOM? Well, it's a framework called Blazor, and the framework Blazor is written in C#. And you are writing your code in C#. That's all it is happening. For example, when I click on this, create, I'm saying load to-dos. When I load to-dos, the array got changed. And then because of the array change, well, Blazor is smart enough to go and then repaint this table. Let's me take a look at another question. Is Blazor production ready? Have you used it in production? Oh, by all means, I'm already running Blazor in production. I cannot say where, when, who, because it's for a Malaysian financial company. I can't name it here, especially in this public forum. But we have used Blazor in production, not a problem at all. It just does what it's supposed to do. And then I've been building this kind of small utility applications on Blazor for, I don't know, 3-4 years now, because I know JavaScript. It's not that I don't know JavaScript, but it's just that being in C#, it's so joy. You know, we work with the same constructs, we work with the same code syntaxes, everything. It's the same. I'm not jumping out of everywhere. Once you go into the JavaScript land, believe me, it's a lot of confusion there. Okay, Asif is saying I've used Razer but not Blazor before, but it looks advanced form of web forms. Advanced form of web form. I wouldn't say advanced form of web form because there is nothing that you are pretty much doing like a web form. This is a typical front end technology paradigm. Let me show you the uh, where is our index? Yeah, if you're worried about like, oh, this is web forms. No, in web forms, you couldn't write code inside your HTML because everything was a web control and you did not have control over the web control. That's the irony. This, what you see here is nothing new. Angular does it, React does it, Svelte does it. It's a binding expression. All I'm saying is I want you to bind it. Well, there is one more way. If I don't want two-way binding and I just want to display whatever is in the logic, I could always say value is equal to @new to do text. Notice the IntelliSense. Visual Studio is smart enough to give me that intelligence that you have this variable. Okay, probably you're looking for that. But if I do this way, if user changes the text in the text box, my logic will not get updated. I won't get the updated value into the logic. It's simple. It's a front end and back end kind of a concept. It's in web forms. You had a label and then you click a label, then you had to go and then say label.txt, you have to read it. It's exactly the same. All I'm doing is I'm saying by doing bind, this is a short form syntax that Blazor provides me, which is to say that, by the way, please bind value of this variable to the value of the element. And if the value of the element changes, bind it back to this logic, this particular variable in my logic. That is all it is doing. And then even Angular does the same thing. On an element, you can go and then write attributes and saying like, okay, by the way, if somebody clicks on it, I want you to execute this JavaScript code. It's exactly the same. I'm saying execute this C# code. And this gets executed on the browser.
Okay.
How we handle dynamic user roles for authentication using Blazor via API. Keep in mind, authentication authorization is not the front-end framework thingy. It's how you have implemented in your backend. I'm using Azure Active Directory for authentication. Okay, Blazor has a hook into that Active Directory, and then it will tell you whether he's authenticated. Once a user has been authenticated, we look for scopes in the token, right? And then I can use that scope and then tell Blazor that, look, this index can be used only by admin scope. So that means you need to make sure that you have set up your user, you have set up your Active Directory, you have set up your grouping, you have set up your scopes correctly on your Active Directory. And then in the token, you got to send like, oh, this guy's scope is admin, this guy's scope is user. Based on that, you control it. There are different ways of different people do it differently, but it's not Blazor's responsibility. Blazor is a framework.
Yeah, sure. Thanks.
Yeah, Roderick has a question. Are the load times in real world production environments so with a larger code base acceptable, or are we talking actual seconds in your experience? Yeah, that's a kind of a, it's like toffee or whatever. It's like you always have this question about should I worry about the time or should I not worry about the time in terms of the payload itself, right? When single page application started, we had the same. Oh, jQuery. Oh man, it's a fat API library, but I cannot live without it. So it's exactly the same situation we are in. Microsoft currently is trying to see if it can cut down the what do you call as the payload time. How currently what is happening is our DLLs are not WASMified as we call it, meaning my DLL that goes to the client side is pure, C# DLL. It's not WASMified. Why? Because the .NET runtime is WASMified, and it knows how to read this DLL and then execute the instruction, but not my code. My code is going as is, and then currently, I think we are now on .NET 5, and .NET 5 is not WASMified. So that's why it's pretty much it's getting a huge payload down the thing. There is no tree shaking, as we call it, meaning I used a lot of DLLs, but I don't know how many of them are in use within my applications. What Blazor is doing is, you need this, okay? You told me this package, I'm going to get everything. So those kind of things Microsoft is working towards. Ahead of time compilation is nothing but, yes, we're going to WASMify the whole project and then send it. It's going to be much smaller in size compared to the size that I have now. Having said that, Microsoft is doing a lot of things on the performance side. Personally, I don't feel that it's going to be a huge factor. Keep in mind that the load time is going to be slightly higher for the first time on any browser. The moment the files are all cached, it's okay. It comes back in 3 seconds. 3 seconds is an acceptable timeline. Having said that, if you think that because of my size, Blazor WebAssembly is not my cup of tea, but I want to be in Blazor, you can always look at Blazor server side. What happens with Blazor server side is every interaction user does here in the browser, a notification goes to the server, and server prepares the point in time UI and then sends it back to the server. Meaning when I click on create, the click event goes to the server, and in the server you will prepare the next frame, as we call it, of the UI, and then the next frame is generated and then sent back. It's hardly anything. So if I can show you the difference, if you go to I think it's mudblazor.com, or you can go into any examples of Blazor. So this one is in fact built with Blazor. So these guys are a open source project. They provide material design components for Blazor, and they have built this website using Blazor. Currently, when you go to mudblazor.com, this is running as a Blazor server side. And notice here, it says switch to WASM. So what I'm going to do is I'm going to bring both of them side by side. And one I'm going to go to WASM. The other one I'm going to go to server side. So the right hand side is a Blazor server side. The left hand side is a Blazor WASM. And notice what happens when I refresh the server side. It comes instantaneously. Screen is not visible. Asif, are you able to see my screen?
Yeah, I'm able to see.
Video is visible. Interesting. You should have, Teams will actually give you two windows. One is the screen being shared, and then somebody is saying I can see two Blazor windows. Yes, I can see two Blazor browsers. Yeah, okay, thank you. So the right hand side is the Blazor server side. When I refresh, it's very instantaneous. That's because nothing gets downloaded to the client side. Everything is built on the server, and the whole DOM is sent to the browser. Okay, the left hand side is the same page, but it's a WASM, meaning it's a client side, and you will see a little bit of loading and then it comes up 3 seconds. That's because everything got downloaded to the server. Now let's do something. I'm going to click on this guy, the left hand side. It's happening on the client side. This is happening on the server side. When I clicked on it, in order to open it, it has to go to the server and then come back and then do that. And then I'm going to click on components. And now let's take a look at this. When I click on this particular alert, it has to do a routing. The left hand side being the WebAssembly, the routing happens on the client side. The right hand side being the server side, what happens is when I click on it, it has to go to the server, and then it's like, you need to go to the second route. Okay, I'm going to prepare that route, send the whole thing there. So the right hand side I already clicked. It's coming up. Left hand side, sorry. It's slightly faster on the WebAssembly. Why? Because, well, the routing happened on the client side, whereas this guy, anything that you do on the file here, I mean, clicks anywhere, goes to the server. So it's two variants available. The server side uses SignalR because it has to keep a continuous connection between this browser and the server. So if you have a high traffic, you need to make sure that you scale up your SignalR. So two variants are available. We take a look at the what kind of project is this, and then we make a decision whether we want to go WebAssembly or we want to go server side. If the client says that no, I'm very much particular about load time, we go server side. Is like, no, I don't mind anything, it's fine, then we go WebAssembly. Why? Again, there is a cost aspect of this, right? If you're okay with Blazor WebAssembly, I do not have to take an app service plan. I do not have to take an Azure app service at all. I can host it as a static app, or I can host it as a static storage site. I pay like a penny to host my site. Whereas because it is a server side, you need an ASP.NET server. In order to get an ASP.NET server, you need the app service plan. In order to get app service plan, you need app service, you need to get an app service plan. App service plan is built per hour. So it's all this ifs and buts that you need to sit through and then take a look at it. The whole concept, the whole question about load time, the payload size. I remember the same thing we used to ask during the jQuery's time, right? It's exactly the same, but more and more Microsoft does performance improvements. We're gonna see a lot of better thing, and not only that. Um, Blazor client side in the latest release has come up with lazy loading, meaning currently I'm loading everything that, let's go back to the to do. Let's assume there is one more screen, 5 more screens. Maybe one user never goes to the screen 2, screen 3, screen 4. But if there is no lazy loading, I'm loading the whole website in one shot, right? So there is a concept of lazy loading. I can tell Blazor that by default, load only my to do, this screen or this component or this route called to dos. Do not load anybody else. But if I had another route here, when I go to that route, it can be lazily loaded, meaning it goes to server, gets the DLL required for that particular component or whatever, and then starts loading the page. So there is a concept of lazy loading. You can make use of that lazy loading also if you're worried about the size, payload, all those things. With a larger code base, it is acceptable. Well, yeah. So the more you have a bigger code base, yes, it has to download everything, assemblies that you have kind of referenced. If you don't do lazy loading, it's going to load the whole reference that you have. So of course it's going to be slow. Where is it more helpful? If you are an enterprise, you're running this application within your data center or whatever, or even in Azure. Well, yeah, within your intranet, not a problem because you're already on a good bandwidth. So yeah. Yes, the lazy loading is the magic word here. Yes. Yeah, I didn't do the lazy loading because I have only one. Next question, how do we modularize the application in Blazor similar to components in Angular? Oh, very simple. Let me show you very simple component now. I'm going to do a component now. Components are very simple. I'm going to say Razer component. And let's say we're going to do a greeting component. OK, greetings component. So what is a component? Component is nothing but a mechanism to pretty much kind of reusability, right? So I'm going to say, yeah, let's make it h3 hello, and then I will say use name maybe. So now this is a component, but I need to get the name into this component. So what is the name, right? So I can do this way now. I can say this component exposes a parameter. The parameter is a public string. Oh, let me use prop. It's a public string name, right? That's it. So now he's going to get it here, right? And then let's say, yeah, I'm going to keep it at this to make sure we're on it. And now how do I use it, right? Very simple. I already have user email. So what I'm going to do is Contoso to do apps greetings name equals @user email. That's it. This is a component now, right? Now, if I go to my website, there you go. I got my component. So modularization, it's up to you how you modularize. I use what's called as there's a famous word. I forgot the word. Basically, we go feature folders. If I had to-dos, I'm going to create a folder called to-dos, and then everything inside everything related to the to-dos is going to be inside that folder. Like that, it depends on you. And then um, Blazor is great because you just create a Razer file that becomes a component. Right? Notice here I have a login. Oh yeah. So take a look at this. You see this? Hello Lohith GN logout and then about. That's coming from this login display. If I am authorized, it will say hello Lohith GN and then it will say logout. Else it will say login. So this is a component. I'm reusing this in my layout. If you see the layout, I'm putting that component there. Not only that, my navigation menu that you see on the left hand side, this is again a component nav menu. And then I put everything related to navigation in this one. And then I also have all the logic required for that. And then how do I use it? Well, I just say nav menu. That's why Blazor is very, very cool. You just create file, it becomes a component. I can reuse the component in whichever way I want. We are reaching almost like 1.5 hours. I don't want to hold anybody for lunch, dinner, all those things. So maybe last 3 minutes we close out. Any more questions, please go ahead. Otherwise, thank you very much. That's all I had for this series, 4-part. All the parts will be made available in YouTube. The 3 parts are already there. Yeah, I mean, I can come back and then do a Blazor alone on some day, maybe in future. Let's see, where I showcase all the different bits of Blazor, starting from getting started to all the way to complex lazy loading, all those things. Maybe someday in future. But otherwise, this was just to showcase that you can start from Azure Serverless Functions with C# as a language, OpenAPI spec, and then end up in a Blazor client communicating with this API. That was the whole idea about showcasing real world end-to-end application. I built an API, I have a consumer, well, end-to-end full stack C#. So thank you. And then I hope you learned a lot in this 4 series. You feel free to contact me. I'll just put my, so that's my email ID. I'm not on Twitter. I'm not on Facebook for a reason. Any pointer on Azure Function DI? Interesting. I think we covered this in the part 2. The dependency injection is something which we do a lot in functions. That is all it is. You need to create a file called startup. Okay, before that, you will need to include a package called Microsoft Azure Functions extensions that is required. This is the guy who provides you this particular class called functions startup. You create a class called startup.cs, add an assembly attribute, and then say function startup. And this is the class. And in the class, you inherit from function startup. Then you get only one thing called configure in the override. And then this is the function host builder. And you add all your dependencies here. Notice here I have a to-do DB context, to-do service. If you look at my functions themselves, the functions are relying on only 2 things, on a configuration and then a service. That's it. And then it says like to-do service, go ahead and then give me this list to-dos async. That's all it is doing. And this is all DI, mind you. I'm not newing up anything here. This is all injected by the dependency container. More questions? We have 1 more minute. Yeah, so there's a link to all the parts. It's on YouTube. Today's probably is going to go online in probably by tomorrow. You will have this fourth part.
Yeah.
Yeah. So if you have any questions, feel free. Otherwise, we can call it a day.
Okay. Thanks, Lohith. Really nice session and wonderful series for all parts. So, hi guys, if you have any questions, please you may unmute yourself, you can ask. And if you want to ask later on after watching the video series, so you can email to Lohith or you
Yep.
can connect any one of us. So we'll yeah, communicate with Lohith to you. And our next session will be on 25th March. We will announce soon. So yeah, that's for today. Thank you very much for joining the session today.
Thank you, and then have a great evening, night, wherever you are from.
Thank you, Lohith. Thanks, everyone.
Okay, so
Yeah.
see you.
See
Bye.
you. Bye.